Heat and energy. Heat is the energy associated with the motion of particles. An ice cube feels cold because heat flows from your hand into the ice cube. So remember that solids are very, very packed, tight particles, highly attracted towards one another. And then if you add heat, particles speed up, causing them to move further away and form a liquid. So as the ice cube goes into your hand, the heat from your hand will go into the ice cube, forming those particles to move faster, and then your hand cools down because it's releasing some of that energy. The SI unit of energy and work is the joule. Another familiar unit is calorie, which is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. You can go between calorie and joule, kilocalories and calories, kilojoules and joules as well as these conversion factors. And you can also go that 1 kilocalorie is equal to 4.184 kilojoules. So let's put this into work. The energy needed to keep 75-watt light bulb burning for 1 hour is 270 kilojoules. Calculate the energy required to keep the light bulb burning for 3 hours in kilocalories. So given 75-watt light bulb, and that in an hour there's 270 kilojoules of energy used. So 270 kilojoules per 1 hour. Calculate the energy required for 3 hours. So we want energy in kilocalories for 3 hours. So we know that kilocal and kilojoule have this conversion factor. And you can also use any other conversion factors and make it multi-step or single-step. Just depends on what you want. So since I want to end with kilocalories, this is my ending point. I know that I'll have to place my conversion factor in here somewhere, which means that I'm going to need to use that amount of energy per hour. And then to get rid of those units, I will need to use the 3 hours. And there's your plan. So you take your 3 hours times 270 kilojoules per hour times your conversion factor. And then you double check hours cancel, kilojoules cancel. You'll be left with kilocalories. You didn't use a 75 watt, but if you reread the question, it makes sense as why you would not. The energy needed to keep a 75 watt light bulb burning for an hour is 270 kilojoules. So to keep this particular light bulb burning for an hour, it takes 270 kilojoules of energy. Calculate the energy required to keep that light bulb burning for 3 more hours in kilocalories. So you're talking about this light bulb. You're not changing anything about this light bulb. You just want to know how much it would take to burn it for a little bit longer. All your units cancel and you plug it into your calculator and you get 193.59. And then you check your significant figures. You have 2, 2, and 2. So 190 kilocalories would be your answer.